This presentation is designed to help you understand the physical and health hazards posed by chemicals with which you work. In the next few minutes, you'll learn about chemical warning labels, material safety data sheets, and personal protective equipment. Our goal is to help you recognize situations in which chemical hazards are present, be able to select appropriate personal protective equipment, interpret and understand warning labels, and understand material safety data sheets. More than 30 million workers are exposed to chemicals every day, and there are more than 500,000 existing chemical products used in industry. Your safety on the job depends on your ability to lower your chances of exposure to chemical hazards. OSHA requires that employers like North American maintain a hazard communication training program, discuss employee protective measures, and review the program on an annual basis. North American is also required to discuss container labeling requirements, material safety data sheets, and to provide hazard communication and chemical hazard safety training to all employees who might contact chemicals. This presentation is the first of a 3-session series designed to meet and exceed all OSHA regulatory requirements. This module deals with hazard communication as defined by OSHA in 29 CFR 1910.1200. The second presentation focuses on safe work practices required by the North American galvanizing process. The third session will be made up of chemical-specific safety training meetings. This is WorkSafe Hazard Communication Safety Training for North American Galvanizing Company. Welcome! First, some background information. Hot dip galvanizing has been around for over 150 years. While the principles have remained unchanged through the decades, North American Galvanizing continually strives to improve the safety and quality of the process. The North American Galvanizing network of facilities began providing hot-dipped galvanizing services in the late 1950s. Over the years, our plants have continued to offer high-quality, cost-effective solutions to the world's corrosion problems. Today, North American Galvanizing continues to offer the highest quality coatings and services in the galvanizing industry. Ongoing construction of new, state-of-the-art facilities and the addition of other corrosion control products have kept North American at the forefront of the industry. North American Galvanizing Company is the core subsidiary of North American Galvanizing and Coatings Incorporated. North American Galvanizing is a leading provider of coatings for corrosion protection of fabricated steel products. We have a network of plants located in various cities: in Canton, Ohio, Denver, Houston and Hurst in Texas, Kansas City, Nashville, St. Louis, Louisville, Kentucky, and at our company headquarters in Tulsa, Oklahoma. Hot dip galvanizing provides metal corrosion protection for steel products in commercial, construction, and industrial markets. Our mission is to deliver to our customers high-quality galvanizing services in a safe manner. North American's hot dip galvanizing and InfraShield coating systems offer proven solutions to America's corrosion problems, and we hope you'll take pride in the job you do. Hot dip galvanizing is a complex process. At North American, you risk daily exposure to chemicals and toxic materials. Our goal is to help you become familiar with techniques and information that can help lower your workplace exposure. A vital tool in your effort to work safe is a material safety data sheet. An MSDS contains vital information about potentially hazardous chemicals. Each MSDS contains 9 sections. First, product identity. Second, hazardous ingredients. And third, physical and chemical characteristics. The next 3 sections include fire, explosion, and physical hazard data, reactivity data, and health hazards data. Sections 7 through 9 focus on precautions for safe handling and usage, control measures and protection information, and any additional information and special precautions required. Any information withheld from an MSDS is a trade secret must be provided during an emergency or at the request of a physician. Information users must agree to keep this information confidential. In an emergency, the manufacturer must provide the information immediately upon request. Your choice of personal protective equipment, or PPE, is often dictated by the relevant material safety data sheet or job procedures. We'll discuss PPE later in this presentation. Whenever you have a question about PPE, be sure to ask your supervisor. North American Galvanizing maintains a labeling program for hazardous chemicals. The program is reviewed annually. We train all employees who may come into contact with hazardous chemicals. Each label uses the same name as appears on that chemical's material safety data sheet. All chemical containers must be labeled unless the container is portable, contains a chemical intended for immediate use, and remains in the hands of a specific individual. It's important to remember that no container resembling a drinking glass or cup can be used for chemical storage or containment. Each label contains 4 hazard parameters. These include a health hazard, a flammability hazard, a reactivity hazard, and a specific hazard. Let's take a look at a sample label. Each of the 4 squares within a square covers a single parameter. Yellow is reactivity, while red is a fire hazard designation. Blue is health hazard. White is a special or specific hazard unique to this particular chemical. Hazard levels are rated in descending order. Generally speaking, a hazard marked 4 is severe. When marked 3, the same hazard might be considered high or serious. Marked with a 2, that hazard would be viewed as moderate, and 1 indicates only a slight hazard. 0 means the hazard is minimal or insignificant. For example, a blue square, a health hazard, marked 4 may be fatal on short exposure and would require specialized protective equipment, whereas 3 would be corrosive or toxic, requiring you to avoid skin contact or inhalation. A 2 would be harmful if inhaled or swallowed, and a 1 means the chemical may irritate your skin. A flammability hazard marked 4 means you're dealing with a flammable gas or extremely flammable liquid. A 3 means the liquid is flammable with a flash point, the point at which the liquid ignites, at less than 100 degrees Fahrenheit. A 2 means the liquid flash point is somewhere between 100 and 200 degrees Fahrenheit. A reactivity hazard marked 4 means the material is explosive at room temperature. A 3 means the material may be explosive if shocked, heated under confinement, or mixed with water. A 2 means the material is unstable and may react violently if mixed with water, while a 1 designates a reaction to water that is not violent. 0 means the material is stable when mixed with water. In the white special hazards section, a W means the chemical is water reactive. The designation OXY means the chemical is an oxidizing agent. Become familiar enough with the labeling standard that you can easily and quickly identify the dangers posed by the chemicals you handle or use. With practice, a quick glance is all that's required to tell you about the specific hazards of the substance you're using. The hazards you are likely to encounter in the North American workplace are broadly divided into 4 categories: air contaminants, acids and bases, solvents, and metals. Air contaminants include gases, usually gases in compressed form. Vapors are formed by evaporation of liquids and solids. The amount of the vapor usually depends on the exposed surface area, the temperature, and something called the vapor pressure of the substance. Fumes are usually metallic, formed by welding, cutting, or brazing operations. Inhaled fumes can be extremely hazardous. Particulates are composed of solid or liquid particles suspended or dispersed in air, like dust, mist, or smoke. While some particulates are relatively harmless, others can be explosive in nature. Breathing them is an extreme hazard. Air contaminants may seem nothing more than a nuisance, but gases, vapors, fumes, and particulates can enter your body through the lungs, through the skin, even by injection or ingestion. The important thing to remember is this: air contaminants may be deadly, so it's important that you know about the contaminants to which you may be exposed in the workplace. Liquid chemicals are broken down into acids and bases, depending on the pH of the liquid. pH factors range from 0 to 14. Neutral pH is 7.0. Above that, the liquid is more alkaline or base. Below 7.0, the liquid is more acidic. Some acids commonly found in the workplace include hydrochloric acid, nitric acid, and chromic acid. Common bases include sodium hydroxide or lye and sodium hypochlorite or bleach. Acids and bases are often incompatible with each other, and neither may be compatible with you. If you're unfamiliar with the chemical, find out whether it's an acid or a base. Read the material safety data sheet. Read the label and look for specific written warnings. Take some common sense precautions around chemicals of any type. For example, ensure your work area is well ventilated and don't eat, drink, or smoke around chemicals. Wear appropriate personal protective equipment and change your clothes when you finish at the end of the day. Don't take the same clothes home with you. If you spill an acid or base, clean it up. Don't risk the spill being mistaken for water. For spills of any size, contact your supervisor or the safety officer immediately. Store acids away from bases to prevent chemical reactions. Know the reactions other materials will cause with the chemical you're using. Unless you are rebuilding a tank that's been drained, always add acid to water. Never add water to acid. Organic solvents contain carbon. Common organic solvents include gasoline and acetone. If you use them in an unventilated work area, these solvents can affect your central nervous system. Aqueous solvents contain water. Solutions of acids and alkalis are usually classed as aqueous solvents. If the amount of chemical in the air produces an unsafe concentration, engineering controls are usually required. When engineering controls aren't adequate or are not available, respiratory protection is required. If you breathe solvents, you may notice a headache, dizziness, confusion, or drowsiness. But the health hazard doesn't stop there, because different solvents seek different target organs in your body. The same common sense rules apply when you're using solvents. Read the material data sheet. Read the label and look for specific written warnings. Ensure your work area is well ventilated and don't eat, drink, or smoke around solvents. If you find you are sensitive to solvents, and some people are, you can use a barrier cream to protect your skin. Know all the possible reactions that can be caused by the solvent you're using, and remember that solvents can be inhaled, ingested, absorbed, or accidentally injected. Remember that the intensity of the solvent's odor isn't a good indication of how toxic the solvent is. Less odor could mean more danger, and more odor could mean less danger. Because so much of your work at North American Galvanizing involves metals, you should be aware of the hazards that metals pose. Metal particles can come from several types of operations, including abrasive blasting and deburring. Metals can enter your body through inhalation. Small particles are trapped in the lungs and absorbed into the bloodstream. And metals can be ingested, either by eating, drinking, or smoking without washing your hands, or by using contaminated consumables. Metals can also be absorbed through the skin or mucous membranes. When metals puncture the skin, small amounts can be injected beneath the tissue. Sometimes compressed air can cause the injection of metals as well. The galvanizing furnace temperatures are not hot enough to create metallic fumes, but certain other operations, like welding and cutting with a torch, can. Metallic fumes are made up of tiny solid particles, which are the condensed molecules of vaporized metal. If your work area lacks proper ventilation, the effects on your body can be disastrous.